Welcome back. Today, we're exploring stratigraphy, which is the study of rock layers and their history. In this video, we'll break down essential principles, key rock formations in India, and some fascinating geological processes. Let's dive in. Principles of stratigraphy. Stratigraphy is all about understanding the layers of rocks, also known as strata, and how they formed. Some key principles include superposition. In a sequence of rocks, the oldest layers are found at the bottom, and the youngest are at the top. Original horizontality. Sediments are usually deposited in flat, horizontal layers. If they aren't flat, something must have happened to them later. Cross-cutting relationships. If one rock feature cuts through another, it's younger than the feature it cuts through. These principles help us read the geological history recorded in rocks. Stratigraphic nomenclature. Stratigraphy has its own rules for naming rock layers, making it easier to identify and describe them. Three main methods are lithostratigraphy, where rocks are classified based on their physical characteristics. Biostratigraphy, which uses fossils found in the rocks to date and match layers across different areas. Chronostratigraphy, which focuses on when rocks were formed, using tools like radiometric dating. Together, these methods give us a deeper understanding of Earth's past. Correlation. Moving on to correlation, this process is how geologists match rock layers from different locations. They compare factors like rock type, fossils, and the age of the rocks. This helps create a unified geological time scale, which divides Earth's history into different periods. The geological time scale. The time scale organizes Earth's 4.6 billion years of history. It's divided into significant time periods, like the Precambrian, which covers most of Earth's history, and the Phanerozoic eon, which includes eras like the Paleozoic, Mesozoic, and Cenozoic. These eras are marked by important events like the rise of life, the age of dinosaurs, and the evolution of mammals. Precambrian rocks. Dharwar and Proterozoic. In India, some of the oldest rocks come from the Dharwar and Proterozoic systems. Dharwar rocks are ancient metamorphic rocks that contain important minerals like gold and iron. The Proterozoic rocks, on the other hand, provide clues to the early atmosphere, tectonics, and the beginnings of life on Earth. Cuddapah and Vindhyan systems. The Cuddapah and Vindhyan systems are significant rock formations from the Precambrian era in India. The Cuddapah basin in southern India contains valuable minerals like limestone and uranium, while the Vindhyan basin, located in central India, is known for sandstone, shale, and limestone. These rocks hold vital clues about early life on Earth and have important economic uses. Phanerozoic rocks of India. India also has several important Phanerozoic rock systems that give us a glimpse into the country's geological history. For example, the Triassic rocks in Spiti contain marine fossils, showing that much of India was underwater during that time. The Jurassic rocks in Kutch are famous for fossils of marine reptiles and dinosaurs, marking the presence of a shallow sea in that region. The Gondwana system is known for its coal deposits and fossil flora, including the famous Glossopteris plant. The Cretaceous rocks of Tiruchirappalli, also known as Trichinopoly, are rich in dinosaur fossils and show evidence of significant tectonic events that shaped southern India. The Tertiary rocks of Assam are crucial for oil exploration, formed after the collision between the Indian and Eurasian plates. Major boundary problems. There are a couple of important boundary issues in stratigraphy. The Cambrian-Precambrian boundary is tricky to define because the Precambrian has limited fossil records, while the Cambrian marks the explosion of life forms. The Cretaceous-Tertiary (KT) boundary is known for the mass extinction event that wiped out the dinosaurs. This boundary is often marked by a layer of iridium-rich clay, likely caused by a large asteroid impact. Tectonic framework of India. India's tectonic history is fascinating. The Indian plate separated from the ancient Gondwana supercontinent and moved northward, eventually colliding with the Eurasian plate. This collision is what caused the formation of the Himalayas, the world's tallest mountain range. Evolution of the Himalayas. The Himalayas are still rising today because the Indian plate is continuing to push into the Eurasian plate. The Himalayas began forming around 50 million years ago, and this process still shapes the region, causing earthquakes and mountain uplift.